Ever cramped a routing protocol the night before the exam, then froze when the real router asked you a single question? Well, today I'll show you a dead simple lab workflow that turns theory into second nature skills using three-site EIGRP design you can build under 30 minutes or so. Ready? Let's lab it up. Now here's the truth. The human brain forgets 40% of the new information within 24 hours unless you use it. Labs give you three superpowers if you realize it. Muscle memory, your fingers remember the commands long after the slides are gone. Instant feedback, a red X or a green tells you got it or fix it in real time. In a real world contest, you'll not memorize the port numbers, you're solving an outage before they happen.
Meet our institute, one campus right here, with one main branch, two branches here. Each of them has two connections. In this case, one is a 1 gig, other one is 100 meg. Let's say one of them goes off, you're off, right? So second one is not just even for backup. How about we are able to use by using EIGRP and load balancing, so we can make sure that there are two connections reaching branch one, because a lot of times we're using main branch talking to the branch one, let's say in this case. If you look at these routers here, the main idea here is with EIGRP, rapid convergence and unequal cost load balancing and a tidy route summarization. Think of this as your Google Maps for routers, which always chooses the fastest road plus rock solid backup. If you look at the routers here, those are your hubs. Switches are handling all the VLANs. I've just created three VLANs here, VLAN 10 for Corp, VLAN 1020 for guest, and VLAN 30 for printers, let's say. We'll keep the WAN addressing clean with just its point to point, so I'm just using a 30 subnet. And each branch router can also run a stub mode, so it never floods the network with unnecessary queries if something goes down, which really means is, see, and this is more like a hub spoke setup, which means is this is my hub and these are the spokes, could be a third branch here. So they all just come to the main branch. So if you lose a connection, you're not going to try and look for other route to come to the main branch. That's the idea. Yes, using a routing protocol, but to keep it clean. And if you look at this particular lab, there are a lot of concepts here. So along the way, if you'll see a lot of bit-sized concepts and actions, VLAN creation, router on a stick using sub-interface, which is logical interface. So what are those? Bandwidth statements to balance different WAN circuits, EIGRP basics, hello packets, neighbor tables, the dual algorithm, route summarization for leaner tables, and then EIGRP stub to protect spokes from query storms. So by end, you will know these features, you'll watch to how they can fix real outages before your eyes. Speaking, my choice of tool has always been EVNG in last couple of years, but not everybody has it. So for this particular one, I'm going to try using Packet Tracer. And while I was testing it, I also noticed that the EIGRP stub does not work on that. I tried a few different options to make it work, but again, think Packet Tracer is still just a simulator, so it does not have all the configs that are built into your iOS that's in the real world routers or switches. Now, I'll give you the configs at the end. Those configs can be used on GNS3 and EVNG if you like to lab on those. What we're going to do is, step one, we're going to start connecting these VLANs. We'll name them Corp guest printers, as you see, and tag them to the uplink to the router, right? So that's the trunk we're going to create. And then we're going to create all the sub interfaces on the router. For example, if I'm using gigabit 0/0 and then .10 will be used for subsequent, I would say, VLANs, which we'll talk to you in detail. Now, the idea there is that switch configs are almost identical. Once you configure this, it's pretty much identical. And then for WAN links, as you already see, that I'm just using all the 30 links here, and you see the IP addresses here. And then we start creating the EIGRP. We'll create an EIGRP autonomous number, let's say 100, and make sure that automatically all these routers share all the different VLANs, because don't forget, there are a lot of different networks here, right? I'm sharing all of them. Then I'm summarizing them. Somebody from, let's say, a main branch here is able to ping a PC connected here, will be able to ping somebody right here without doing any static routing. Now, summarization is because a branch is going to advertise, instead of saying, I know how to get here, I know how to get here, I know how to get here, it kind of summarizes everything. So for example, from a branch 1 perspective, instead of saying I know how to reach to 192.168.4.0 and so on, I can just say I know how to reach to 192.168.4.0/22. And if you don't know really what I'm talking here, just search up summarization, and that's a concept you need to know. So that's why I said that there are a few concepts that you need to know. Then variance is that you can also use variance, because see, if you have two connections, let's say one is a 1 gig, other one is 100 meg, the idea here becomes is if I use variance, which both circuits can also be used simultaneously, so they are both carrying traffic. Okay, so that's something we're going to try here. As I said, we're going to use packet tracer. That's your packet tracer. That's the lab I built. Exactly what you saw. Now there's no cloud here because these connections are direct. Now these, in real world, let's say if these are your MPLS connections, or today's world, you see less and less of those, which really means is it could be a firewall and you're connecting VPNs, IPsec tunnels. I won't go there, but that's just the idea. What you can do really is you can just drag and drop 3 routers, which are 2911s. If you look at the routers here, right? So I can use the 2911s, 3 of these, or you can use the switches. Now, the only thing you need to remember is these routers don't come with, so let me double click on one of them here. You need to add these modules to them. I've added these modules, and it's pretty much like drag and drop. They need to be turned off. When you do that, once you turn it off, you can actually just turn, it's the toggle switch here, which really means is now the router is on. I had them turned it off, so let me just go ahead and turn all of them on here, right? So let's go ahead and do that. Perfect. Now, from the connection perspective, what I've done is between our, and I like to keep everything consistent, to be honest. So what I've done is with all my switches, all the connection that you'll see is gigabit 0-1 and 0-1 on the switch. And all of the sides are exactly the same from that perspective. Okay, and these are your copper straight through cables that I've been using. To connect the routers in between, I'm using serial cables there, right? So for example, from router R1, which is the main campus, I'm using serial 0, 0, 0, going to router 2, again 0, 0, 0. Okay. Similarly, because I'm using two connections from between these two branches, as I said, one is 1 gig, one is 100 meg. Same way, serial 0/0/1 going to 0/0/1. Okay, but here I have another third one, which is 0. It's going just to the only one, which is serial 0/0/0. Okay, so those are the connections. And as I said, you can use the ports. This is your copper straight through for your switch connections. And end of the day, I've also connected one PC each on fast Ethernet. And the port I'm using here is 0.1. So we're only looking at VLAN 10 at this point, right? Now, obviously, if you want to test all the different VLANs, you could have connected 3 devices behind each switch, each on different VLAN. That would still work. Okay. Now let's start to look. And one more thing that I personally always like to do is I like to build my configs instead of going step by step and testing it. I like building my configs in Notepad++. It's a free tool, by the way. What I'm doing here is I'm just saying, let's get into the config mode, which is the global config mode. You start creating VLANs. So VLAN 10, and then it basically creates the VLAN and it labels that as Corp. Similarly for 20 and 30, right? And these are your logical layer 2 segments for Corp PCs. This one, and we'll connect a PC to it. The next thing I'm doing is that's the connection to the router, right? The trunk to the router. If you notice, I'm saying I'm entering into that mode. I'm saying you are a trunk, which means I can carry multiple VLANs. And encapsulation is usually you can use 802.1q, and a trunk carries multiple VLANs to the router sub interfaces. Another thing I'm doing is I'm only limiting it to, it's kind of a security as well. So only tag 10, 20, and 30 and block any other stray VLANs that are coming in. So keeps the trunk clean in that way. And then from an access perspective, select the fast Ethernet port. And I'm saying because I'm going to create these local PCs. So fast Ethernet 01 is where it's going to be VLAN 10. Okay, so going back to our diagram here, this PC right here is in VLAN 10. Okay. Now, once you've done that, the next thing you want to also look at is now you want to start looking at your configuration of your router. So let's go ahead and take a look at that. So let's go there. That's my router 1. So similarly, nothing different here. Just giving it a host name, interface gigabit 01. No shut means I'm going to try and bring it up. And then you see the sub interface come in. This is the part you're going to be doing the router on a stick. So these are the sub interface for router on a stick. And it creates logical interfaces tagged for VLAN 10 in this case and assigns an gateway IP, which is 192.168.1.1. And obviously I'm doing a /24, or you want to say 255.255.255.0. Okay. Now, the idea here is that the Corp PC reaches layer 3 and advertises a subnet into the EIGRP because it's a network here. And I'm going to repeat the same exact thing for 20 and 30, so nothing different there, right? We get to the sub interface. So this was the connections serial interface, and I'm going to actually assign it an IP address, and I'm using a /30, so that's why you see at the end it's a 254. There's a clock rate you're giving, it's a serial link, and then its bandwidth is this, which is in kilobits per second, which is equal to 1 gig. Okay, I'm saying no shut, making sure this interface comes up. Similarly, for interface serial 0/0/1, giving an IP address here. I'm just following my diagram at this point. Bandwidth, if you notice, is one less, which is 100 meg. Okay, and then similarly, the other connection it has to the branch 2 or router 3 is also a 100 meg connection. Okay, and then where we start to go into our EIGRP config, starts the EIGRP AS autonomous system 100, all routers must match this number to make sure that we are, so all the routers we have, 1, 2, and 3, they all need to be in AS 100. And when you're running these commands, all you're saying is run EIGRP on any interface that is 192.168.1.0/24 VLAN. And then that's the wildcard you're using. Okay, which is pretty much like the inverse of a subnet mask if you don't know what a wildcard is. And that's pretty much it. So we're going ahead and advertising all of these, which we're going. Now, the next thing that you'll see is you're seeing a variance. Variance means I'm trying to include both 1 gig and 100 meg connections to branchment for unequal cost load balancing, which means I want to try and use both if possible. And no auto summary that you see here is I'm disabling legacy class full summarization. And this I'm hoping that everybody understands what a class full and a class less is. Class full means you have standard /24, a /8, and /16. Another one option I had is this. This is like if you want to, this used to be how old devices used to work, which I have it in a diagram. I'm going to configure it, which means is now these are all set up by your local, let's say, service provider giving you MPLS connections. But what about if I want to go to the internet? That's where usually all the branches would hairpin all the way back to the main branch and then go to the internet. That's where the default gateway is to go to the internet. If you want to test that out, that's where this command is for, if you want to use it. But if you don't want to use it, just test the IP EIGRP, then the first configuration is absolutely fine. Now let's go to router 2 here, and let's see what the router 2 has here. If you look through the interfaces, same idea. You have interface 01, which is no shut, which means I'm going to bring it up. Once it's up, I'm creating a sub interface 10 here, tag for VLAN 10 Corp, and it assigns it a gateway as well, which is 192.168.4.1/24. And exactly same thing I'm doing for my guest and my printer subnet, so done that. And then you come to the serial interfaces. So the same serial interfaces that I created on the other side, now I'm basically creating the same ones on my branch on this side. So I'm configuring this interface and this interface right here. Okay, so let's go ahead and do those. And once it's done, and you'll notice that these are all /30. That's why you'll see a 252 at the end. Okay, and if you're wondering that in my other config here, I had the clock rate, and I'm not having any clock rates here. Okay, that is because it's a DTE side, which means this one is getting its clock from the other side. Today in the real world, I don't see a lot of serial interfaces. And that's why, as I said, if you're using Packet Tracer, that's kind of the limitation you have. It's still an old simulator that you have, so it comes with older technology. Some of the commands don't work either, but that's the ease of using Packet Tracer is there, absolutely. But then there are limitations that comes with Packet Tracer when you're trying to learn. That's why, as I said, I always prefer using the EVNG or GNS3. Perfect. Now we're doing the same exact thing for this interface, the second/30 link, which is the 100 meg backup. Done that. Now we start getting into the EIGRP config. We make sure that the AS number is exactly the same. It must match, as I said, R1 and R2. Right now we're in R2, and we're saying advertise these three. It's saying that which network you want me to advertise. So that's what you're telling the router to do. Once you've done that, then the next thing you want to do is on the each side of the serial interface, it sends a single summary of 22. So in this case, it's sending this one, which means all the 192.168.4.0 up until 7 is all included in this, right? It's help for smaller tables, which really means fast convergence. Right? Disabling the legacy classful summarization here, as you saw before. So all that is similar, nothing different there. Okay. All right. So similarly, if you look at router 3, there is not much here. It's exactly the same config that you'll see. Okay. Now let's start to build this config. Okay, so as I said, the reason I like to do this is, and by the way, I'll make sure that I put all those configs into your description so you can just copy paste the configs and test them yourself. Get going and build the labs. As I said, the easy way to do it is just go to the switch here. That's my lab config, copy it, right? Paste, likes it, perfect. Now let's go to our switch 2. And the good thing is that I don't need to really change anything. I'm not using host name, so I can just copy paste the same config, right? And make sure the configs are done. Similarly, you want to do it for your switch 3 as well. CLI, that's done. Now let's go on to our router. CLI, let's see, it says, would you like to enter an individual config? No, not really. I would rather use my own config. And watch for errors when you paste your configs in case you made a typo. I do it all the time, and that's the reason why I like doing this way, because once I've done it, then I know what's the golden config and what's the config I works for me. In this case, I'm going to kind of exclude the last part of it because I really don't want it to use the ISP option here. Let's get rid of that, paste, and nothing, no real errors. It's just saying that, okay, things are starting to come up. That's a good sign. Let's move on to our router 2 now, CLI. No, right? And then from here, this perspective, let's go ahead and go to the router 2 config, right? So use the enable, all the good stuff. I'm gonna leave this part out if you see the EIGRP stub, because I tried it before I recorded the video, and for some reason, Packet Tracer doesn't like that config. So you can test it. But again, if you're using EVNG or any of the other ones, it would work. So that's a good sign. Okay, so that's done. Router again, CLI. No, oops, I didn't copy. So I'm gonna go to router 3 now. I haven't tested this config, to be honest with you, so I'm really hoping that I didn't make any mistakes, but let's hope for the best. I'm gonna again exclude the stub config, as I said, because it gave me an error before, and open it up. Let's hope for the best. Yep, looks like it's okay. All right. Other thing I've also done is I've made sure that I have the PCs with the certain IP that's in the right VLAN. So if you're wondering how do we do that, IP config, so you'll see this what I have here. So I have 192.168.1.10/24. That's my gateway, which is the sub interface right on the router here. So switch is just a layer 2 device. Okay. Similarly for this guy, it's going to be 4.10 and then 4.1, which is your sub interface on this guy right here. Okay, now let's start to see if we can ping things. Okay, so I tested something before as well. Let's say, first of all, I always like to ping itself just to make sure that I have everything right. Okay, yeah, I can ping myself. Perfect. Now I'm pinging my own gateway, which is the sub interface on the router. Let's see if that goes through, which is right here. There we go. Took some time, came back. All right, now let's try to do the other side. 4.10. Let's see how long does it take for it to come. Right now, let's do another test now, because I have two links going here, right? This and this. How about I do this? I can try and do a -t, which means it's a continuous ping. Hold on. I haven't tried a continuous ping on packet tracers. Let's try 4.10. That's for extra ping so that it keeps on going. So we'll keep that going. And in the meantime, I can go to the router, right? And let's keep the ping up as well. And how about if I now if I show you here, this is the one and this is the one that are both going towards that. So two of them, right? So if I shut this off, let's see how long does it take for the EIGRP to kind of fix it. Okay, so let's go config T, interface, shut, brings it down. Let's see how many pings do we really lose. Not much, right? So both are still there because we have two forwarding. That's the whole idea of having it still with the dual. Now I can just simply go ahead and do a no shut to bring it back up. And now I will notice that it will come up and the neighbors will also change at the same time, right? So that's the power of having routing protocol, like a dynamic routing protocol, instead of using static, because static would have mean that there is some sort of intervention required from an actual admin to get in and actually fix it for you. Once you've done all your configuration, the last thing I would always like to text is to test and verify if everything is up and running, right? This would actually give me, so I'm on router 1 right now. So if I go ahead and actually see who my neighbors are, it just shows me, because I have 3 links on that, tells me what exactly my neighbors are. Other one I only see is what kind of networks can I reach if I'm on this router at this point, right? And you see that. Now, as I said, the interesting part here is what I like to see is because there are 2 ways to reach to that network, because I have 2. And this is where the variance command that we used, that's 2 unequal paths, it's still able to load balance between them because of that variance command that we have. Other thing you can look at it is your show IP EIGRP topology. And all routes are not going to be seen here, especially if they fail the feasibility test. So keep that in mind as well. And that's about it.
All right, a quick remind. Now today you saw how a real-world lab beats memorization every time. We built a 3-site network with VLANs, router on a stick, and a dual WAN circuit. Let EIGRP flex the rapid convergence, unequal cost load balancing, route summarization, and stuff folks that keep the chatter down. Then we yanked a fiber, or the serial port in this case, and watched the traffic shift in milliseconds. Proof that the lab turns theory into instincts. Now fire up your favorite lab tool, recreate this, and use the configs down in the description. If the walkthrough helped, hit like and smash that subscribe button so you never miss a hands-on build. See you next time. Bye for now.